This is a practice paper for the Edexcel GCSE for this year's exam for 2022. It's the paper 1 foundation tier, and the questions in here are based on the advanced information. So the topics in these questions will be the same topics in the 2022 paper 1 exam. On the first page, I've put the formula sheet here. We're not going to be using this very much during this paper. I will come back to it if we do use it. So let's start with question 1. We've got write down the value of the 3 in the number 3091. So the 3 is in the thousands column. It is worth 3000. So we've got the thousands, the hundreds, the tens, and the ones. Question 2, change 1.6 kilometers to meters. So whenever you have kilo, when you ever have this K, it means 1,000. So we've got 1.6 thousand meters. So 1.6 times 1,000 is 1,600. Every 1,000 meters makes a kilometer. Question 3. Here are 4 numbers. So we've got -7, -2, 2 and 7. And we need to write one of these numbers in each box to make a correct calculation. And they have to add up. 2 of these numbers have to add up to make -5. How can we get a -5 out of these? So if we start at -7 and go up 2 spaces, -7 up 2 spaces gets us to -5. We could also have the same 2 numbers the other way round. So we could also have 2 plus -7, which means 2 take away 7. Question 4. Write the following numbers in order of size. Start with the smallest number. So we've got fractions, decimals, and percentages here. So we're going to make them all the same before we can compare them. So if I make them all into decimals or all into percentages, that will be easiest. So I'll choose percentages. So to make a number into a percentage, we can times it by 100. So 0.3 times 100 is 30, so 30%. A third times 100, or a third of 100. A third of 100 is 33.3%. And the 3 will be recurring. It'll be 33.33333 going on forever. We've got 21%. A quarter of 100. A quarter as a percentage is 25%. A quarter of 100 is 25. And to change a decimal to a percentage, times by 100. So that would be 20.5%. So now they're all percentages. We can order them. So we start on the left. So we're going to start in the tens. So we've got 3 and 3 in the tens, and a 2, a 2, and a 2 in the tens. So all the ones with the 2s are the smallest. Then we look at the ones. We've got a 1, a 5, and a 0. So 0 is the smallest. So this will be our first number. Then 1 is less than 5. So that's our second and our third. Then the ones with the 3s in the tens, we'll look at their ones, and we've got a 0 and a 3. So 0 is the smallest, and then the 3. So let's write these numbers down in order from smallest to biggest. So 0.205, 21%, a quarter, 0.3, and a third. Question 5, simplify. So we're collecting the like terms. We can only add C's to C's. and we can only add D's to other D's. So for our C's, we've got 11C, and we're always taking the sign from in front. So 11C plus 5C. And for our D's, we've got negative 8D. Take away another D, another 1D. Whenever you've got D by itself, that means you've got one of them, 1D. So we've got 11C's plus 5C's. 11 and 5 makes 16. And we've got negative 8. Take away 1. Negative 8 down another 1 goes to negative 9. So minus 9D. Question 6. The first term in a sequence is 3. The term-to-term rule is adding 5. So we start with 3, then we add 5, which gives us 8, and then we add 5, 13, add 5, 18, add 5, 23, and so on. Is 97 a term in the sequence? Give a reason for your answer. So you'll see all of these numbers in the sequence are going to end in 3 or 8. So it's going to go 3, 8, 13, 18, 23, 28, 33, 38, and so on. 97 ends in a 7. So no, it's not in the sequence. All terms end in 3 or 8. Question 7. Liam goes to a cafe. He buys 3 coffees for £1.60 each. So we need to work out how much this costs. So 2 teas for £1.10 each, 5 cakes for £2.15 each. Work out the total amount Liam spends. So we've got £1.60. I've just write 160 times 3. 3 coffees for £1.60 each. 3 zeros are 0. 3 sixes are 18. So 8 and carry 1 over. 3 ones are 3 plus the 1, 4. So 480 or £4.80. 2 teas for £1.10 each. 2 zeros are 0. 2 ones are 2. 2 ones are 2. So that's £2.20 or 220p. And we've got 5 cakes for £2.15 each. 5 fives are 25. So 5 in the ones carry the 2 over. 5 ones are 5. Plus the 2. 5 plus 2 is 7. And 5 twos are 10. So what's the total amount? We need to add these up. So we've got £10.75, £4.80, and £2.20 all added together. So the ones, 5 plus 0 plus 0 is 5. We've got 2 plus 8 plus 7. 2 plus 8 is 10, plus 7 is 17. So 7 and carry the 1 over. 4 and 2 are 6, plus the 1 is 7. And we've just got a 1 here. So 1 plus nothing is 1. So I've got 1,775p or £17.75. Question 8. Reflect triangle A in the y-axis. So the y-axis is here. So this is our mirror line. The y-axis is our mirror line. So that's our mirror line. That's the y-axis. So all the points on triangle A are going to be the same distance away from the mirror line on the other side. So it's 2 away to this point. 1, 2. So it would be 2 back from the mirror line on the other side. 1, 2. And 2 away on the other side. And 1, 2, 3, 4. 1, 2, 3, 4. So these are our corners of our new triangle. So we join them up. And that is our new triangle. It looks like a reflection. It's the same on both sides of the mirror line. Question 9. There are only blue counters, red counters, and yellow counters in a bag. There are twice as many blue counters as yellow counters. There are 3 times as many red counters as yellow counters. Write the ratio of blue counters to red counters to yellow counters. So there are twice as many blue as yellow. So for every 1 yellow, there are twice as many blue. So if there's 1 yellow, there must be 2 blue. There are 3 times as many red as yellow. So 3 times 1 is 3. So that's our ratio. So the ratio of blue to red to yellow is 2 to 3 to 1. Question 10. Here is a bar chart showing the scores of 5 students in their maths and English tests. Write down 2 things wrong with this graph. So if we look at this vertical scale here, it's got no label on it, so it doesn't say what it represents. So no label on vertical axis. There also isn't a consistent scale, so it goes up in 4, so up 4, up 4, up 4, up 4, but then up 2 between 16 and 18. So the scale isn't the same the whole way up. So it's not a linear scale or not a consistent scale. So not linear scale. Again, on the vertical axis. And also, there's no key to say which bar is maths and which bar is English. So there should be a key to say what these bars represent. So you could also say there's no key to say what the bars represent. Part B, the pictogram, gives information about the number of chocolate bars sold by a shop last week. So we've got a pictogram here, and we're told in the key that this full circle represents 3 chocolate bars. Write down something wrong with this pictogram. So, well, a whole circle is 3 chocolate bars. So half a circle would be 1.5 chocolate bars. So that, it's not possible to sell 1.5 chocolate bars. It's not possible to sell half a chocolate bar. So on Thursday here, we haven't got a whole number of chocolate bars sold. So on Thursday, the number of chocolate bars sold is not a whole number. Question 11. Mr. Sykes wants to buy a calculator for every student in Year 11. There are 104 students in Year 11. Each calculator costs £6.05. Work out an estimate for the amount of money Mr. Sykes will spend on calculators. So it's an estimate. And we're in a non-calculator exam, so we're going to be rounding these numbers. So 104, if we round to the nearest 100 to one significant figure, that would be 100. And £6 5p, if we round that to the nearest pound, that would be 6. So 100 times 6 is £600. Is your answer to part A an underestimate or an overestimate? Give a reason for your answer. So we've rounded the number of students down and the cost down, so we must be underestimating. It's actually going to cost more. So it's an underestimate. And that's because we've rounded the number of students down and the cost down. So we have rounded the number of students and the cost of a calculator down. Question 12. Last year, Victoria paid £300 for her car insurance. This year, she has to pay £348 for her car insurance. Work out the percentage increase in her car insurance. So for percentage increase, we need to know how much it's gone up by, how much it's changed, put it over the original, and times that by 100. So the change over the original times 100. So what's the change here? How much has it gone up? Well, from 300 to 348 is £48. Over the original, which was 300, and we're going to times that by 100. So how can we simplify this? If we're dividing by 300 and then timesing by 100, we can cancel this. So 48 times 100 over 300, divide top and bottom by 100. So it's just 48 divided by 3. And how many 3's go into 48? So 1 3 goes into 4. 6 3's go into 18. So it's 16. So 16%. Question 13. So here we have a substitution question. L equals 9m plus 2n. Work out the value of L when m is 3 and n is negative 6. So L is 9 times 3 plus 2 times negative 6. And 9 3's are 27. 2 negative 6's, a positive times a negative is a negative, and 2 6's are 12. So we've got 27 take away 12, which is 15. Question 14. So we've got a frequency tree. 60 students study a language at a school. Each student studies French or German. So there are 60 in total. That goes at the start of the tree. 36 of the students are boys. So 36 boys. So the rest must be girls. 60 take away 36 is 24. So 24 girls. 2/3 of the boys study French. So we need to know what 2/3 of 36 is. So we need to know 2/3 of 36. To find 1/3, we can divide by 3. So 1/3 of 36. 36 divided by 3. How many 3's go into 36? That's 12. So 1/3 of 36 is 12. So 2/3 of 36 must be 2 lots of 12, which is 24. So 24 boys study French. How many study German? Well, the rest of them. So 36 take away 24. The other third, that's a 12. 40 students study French. So we've already got 24. We need 40. So how many more? 16 more. And then what's missing? So 16 girls study French. There are 24 in total. 16 to 24 is 8. So those 8 girls must study German. And that is our completed frequency tree. Question 15. Here are the heights in centimeters of 15 plants. So we need to draw an ordered stem and leaf diagram to show this information. So in a stem and leaf diagram, in our stems, we're going to have the tens. So we've got 20s, 30s, 40s, and 50s. So we're going to have 2, 3, 4, and 5. And then we just need to write the leaves as the ones. So I'm going to start with everything with 0 in the ones first. So 40. So that's 4, 0. 4, 0 makes 40. There are no more zeros. So we go with the ones. We've got 41. Another 41. There are no more ones. No more ones in the ones. Then we'll go with the twos. So we've got 32. 52. And 42. There are no more twos. So 3, 33. No more threes. We've got some fives. No fours. We've got some fives. We've got 35. 45. And 55. No sixes. So we've got 47. And then we're on to the eights. 38. 38 again. 48. And finally 29. So we can check we've got 15 numbers in our stem and leaf diagram. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And we've crossed them all off. So we've got a key now. All right, 2, 9. 2 in the stems, 9 in the leaves means 29. And it's centimeters. Question 16. Abby runs a distance of 200 meters in 25 seconds. What is her average speed? So speed can be found by doing distance divided by time. Speed is distance over time. So we've got 200 meters in 25 seconds. So how many 25s go into 200? That is 8. So it's 8 meters per second. Meters per second, meters divided by seconds. So meters divided by seconds. Bonnie runs at an average speed of 4 meters per second for 240 seconds. How many meters does Bonnie run? So it's 4 meters per second for 240 seconds. So it's 4 times 240. You can also say speed is equal to distance over time. So if we multiply both sides by time, we get distance is speed times time. So it's 4 times 240. 4 zeros are 0. 4 fours are 16. 4 twos are 8 plus the 1, 9. So we've got 960 meters. Question 17. Frank needs 150 grams of sugar to make 24 biscuits. He also needs 3 times as much flour as sugar. So let's work that out. 3 times as much flour as sugar. So 3 times 150 is 450 grams. So that's how much flour he needs. And he needs 2 times as much butter as sugar. So that's 2 150s, which is 300 grams of butter. Frank is going to make 60 biscuits. Work out the amount of each ingredient he needs. So we've got the ingredients for 24 biscuits here, and we need to make 60. So for 24 biscuits, we need 150 grams of sugar, 450 grams of flour, and 300 grams of butter. And we need to get to 60. So if you had a calculator, you could divide by 24 to find out the amount for each biscuit. But that's not an option, really, without a calculator. So if we half it, we can find out how much we need for 12 biscuits. So let's half all these ingredients. So it'd be 75 grams of sugar, 225 grams of flour, and 150 grams, half of 300 is 150 grams of butter. So now we've got 12 biscuits. We can either do, we need 60, so we could do 12 times 5 to make 60, or we could do 2 of these, 2 24s, which will make 48, plus the 12, which will make 60. So either of those 2 methods. So I'm going to do 2 of these. So for 60 biscuits, I'm going to say it's 2 24s. 60 is 24 plus 24 plus 12. So 2 of these plus this one. So 2 150s is 300 plus 75. 375. 2 450s is 900 plus 225. So 900 plus 200 is 1100 plus the 25. 2 300s are 600 plus 150, 750. So that's butter is 750 grams. Flour 1125 grams, and sugar 375 grams. Question 18. A cylinder has a diameter of 12 centimeters and a height of 11 centimeters. Work out the volume of the cylinder. Give your answer in terms of pi. So this is the volume of a cylinder. The volume of a cylinder is the area of the base, so the area of the circle of the base, and this is where you can use your formula sheet because this formula is given to us. The area of a circle is pi times the radius squared and times the height, or times the length. And you can also see that in the formula sheet under the volume of a prism. So pi r squared times the height. So we need to know the radius. We've been given the diameter. The radius is half the diameter. So the radius is 6 and the height is 11. So we're just substituting these in. So it's pi times 6 squared times 11. 6 squared is 36. So it's 36 times pi times 11. So we need 36 11s. 1 6 is 6. 1 3 is 3. Then as we're multiplying by a 10, we add a 0. 1 6 is 6. 1 3 is 3. So that's 6 in the ones, 9 in the tens, 3 in the hundreds. So that's 396 pi. Centimeters cubed, which is given for us. Question 19. The diagram shows a cone with radius 3 centimeters and a perpendicular height of 8 centimeters. We need to draw it on the centimeter grid below. Draw the plan and the side elevation. So the plan is the view from above, and from above, looking down on a cone, it will look like a circle. And the side elevation, the view from the side, is going to look like a triangle. So the plan is a circle with a radius of 3 centimeters, and the side elevation is a triangle with a base of 6 centimeters and a height of 8 centimeters. So to draw our circle, our plan, we're going to use a compass. So we'll grab that, and it's going to have a radius of 3. So I'll put my point, I'll put it 4 centimeters from the edge, so there'll be a 1 centimeter gap. I'm going to extend it out for 3 centimeters and draw around. So draw a circle with a radius of 3 centimeters. I've slightly missed a line, but that should be okay. Being very, very slightly off will be okay. Now to draw our triangle. So the side elevation, a base of 6 and a height of 8, and it's going to have to be an isosceles triangle. So we're going to have, it's going to go down 8. 1 2 3 4 5 6 7 8. So this will be the middle of the base, and we're going out 3. So a base of 8, a radius of 3, which means the base is 6. So the base is 6, the height is 8, and that is our side elevation. So there's our plan and side elevation. Question 20. Write 240 as a product of its prime factors. So product is a word that means multiplied. So write 240 as prime factors, prime numbers, multiplied together. So rewrite 240 as prime numbers multiplied together. To do that, we can break the 240 down. So what two numbers multiplied to make 240? It doesn't matter which ones we pick. I usually just start with 2. So 2 times 120. And then that's in the 2 times table again. 120 is 2 60s. And again, 60s in the 2 times table. 2 30s. 30 is in the 2 times table again. That's 2 15s. And 15 is 3 times 5. So they're all prime numbers. Prime numbers can only be divided by 1 and themselves. They've got exactly 2 factors. 2 is only 1 times 2. 3 is only 1 times 3. So let's write 240 as a product of its prime factors. So we can say 240 is 2 times 2 times 2 times 2 times 3 times 5. So 2 times 2 times 2 times 2 times 3 times 5. And if we multiplied all of these together, we would get back to 240. So that's our answer. Question 21. We are subtracting fractions here. So work out 3/4, take away 7/10. To add or subtract fractions, we need to make the denominators the same, the bottom numbers the same. So I can make them both 20 if I multiply my left fraction by 5 and my right fraction by 2. It wouldn't be wrong if we multiplied by 10, 3/4 top and bottom by 10, and 7/10 top and bottom by 4, and made both the denominators 40, but this is a simpler version. So 5 3s are 15, 5 4s are 20. So we're saying 3/4 is the same as 15/20, and 7 times 2 is 14, 10 times 2 is 20. So 7/10, that's the same as 14/20. Now we can take them away. We've got 15 of something, take away 14 of something, that is 1 of something. So 15/20, take away 14/20, that's 1/20. Part B says work out 2 and 1/3 times 3/5. Give your answer as a mixed number in its simplest form. So to multiply fractions, we need to get rid of this mixed number. We need to make it into an improper or top-heavy fraction. So we've got 2 whole ones and 1/3. So how many thirds is that? So we've got 2 wholes and 1/3. So each whole is 3/3. So how many thirds have we got? 1, 2, 3, 4, 5, 6, 7 thirds. So 2 and 1/3 is the same as 7 thirds. You can think of this as saying 2 times 3. So 2 whole ones is 2 times 3, which is 6 thirds. Add on the extra third. So 6 thirds plus a third is 7 thirds. We're timesing that by 3/5. So to multiply fractions, we times the top and times the bottom. So we could times the top times the bottom and then simplify after, which I will do this time. So 7 times 3 is 21. 3 5s are 15. And then I can simplify this. I could have also simplified it before I multiplied. But both of these are in the 3 times table. 21 is 7 3s. 15 is 5 3s. So what I also could have done is divided the top and bottom by 3 before I multiplied. So I would have had 7 times 1, which is 7, and 1 times 5, which is 5. So that's my answer, but it's not a mixed number. So I need to change it back into a mixed number for my answer. So 7/5, I've got 7/5, that's 1 whole one. 1 whole one is 5/5, and I've got 2 more. So it's 1 whole one and 2/5. So a whole in fifths is 1, 2, 3, 4, 5/5, and I've got 2 more fifths, so I've got 7/5. 1 whole one and 2/5 is the same as 7/5. Question 22. In a bag, there are only red counters, blue counters, green counters and yellow counters. A counter is taken at random from the bag. The table shows the probabilities that the counter will be green or yellow. The probability it's red is twice the probability it's blue. So if blue is x, red is twice that, 2x. We can work out what these numbers are because all the probabilities have to add up to one whole. So 2x plus x, which I'll call 3x, plus 0.35, plus 0.2, or 0.20, has to add up to 1. That's everything that can happen, so it must add up to 1. 0.35 and 0.2 make 0.55. Now I'm solving for x, so I'm taking 0.55 away from both sides. So 1 take away 0.55 is 0.45. That's what's left. That's what the red and the blue must add up to. So these two add up to 0.55. There's 0.45 left. So these two must add up to 0.45. So divide by 3. So 45 divided by 3 is 15. So 0.45 divided by 3 is 0.15. So that means the probability of blue is 0.15. The probability of red is 2 lots of that, which is 0.3. Okay, now we're told there are 21 green counters in the bag. Work out the number of red counters in the bag. So 0.35 is the same as 35%. So 0.35 as a percentage is 35%. So we're going to say 35% of the counters is 21 counters. And the red is 30%. So we need to know what 30% of the counters, how many counters is 30%? From 35%, if we divide by 7, divide both sides by 7, 35 over 7 is 5%. So 5% of the counters is 3 counters. And we need 30%. So 35% is 21. 5% is 3. So if we do 35%, take away 5%, that will give us our 30%. So 21 counters, take away 3 counters, that's 18 counters. Question 23. Here is the graph of y equals 2x plus 6 minus x squared. So we've got a quadratic graph drawn for us, and we're asked to write down the turning point of the graph. So a turning point is where the graph turns, where it stops going up and starts going down. So that's the peak up here. What are the coordinates? So it's at 1, 7. So the x coordinate is 1, the y coordinate is 7. Part B, use the graph to find the roots of the equation x squared equals 2x plus 6. So this might look slightly different to the graph we had, but if we take x squared away from both sides, we end up with 0 equals 2x plus 6 minus x squared. So we can see it is the same. It's where y equals 0. Y has just been made to 0. And the roots is usually, the roots are the points where it crosses the x-axis. So it's where y equals 0, y is equal to 0 when it crosses the x-axis. That's where y is 0 along here, along the x-axis. So what can x be to make y 0? So it's either negative 1.6 or 3.6 or 3.6. Question 24. So 5 is less than 2y and 2y is less than 12. So 2y is between 5 and 12, where y is an integer, so a whole number. Write down the possible values of y. So this is 2y, so the best thing to do is to half it. So half everything to make it into a y. So 2.5 is less than y, which is less than half of 12, which is 6. So y is in between 2.5 and 6. It cannot equal them. If it could equal them, there would be an or equal sign here. So it's a whole number, an integer, between 2.5 and 6, but it can't equal 6. So it can be 3, 4, or 5. They are the only whole numbers between 2.5 and 6. Part B. Solve 4 is bigger than 19 minus 3x. When we solve inequalities, there's only one difference between solving inequalities and solving equations, and that is if we multiply or divide by a negative, the sign will flip over. So we can avoid flipping the sign over by making our unknown positive. So if we plus 3x to both sides, we'll have 4 plus 3x is bigger than 19. Then take away 4 from both sides. 3x is bigger than 15. And then divide both sides by 3. So x is bigger than 5. If we had have divided by a negative number, so if we had said take away 19 as our first step, we'd had negative 15 is bigger than negative 3x. And then if we divided by negative 3, we'd have to flip the sign over. If you multiply or divide by a negative, the sign would flip over. And that would mean x is on the bigger side. So negative 15 over negative 3, a negative over a negative divided by a negative is a positive, 15 divided by 3 is 5. So we would end up with the same answer. X is bigger than 5. Question 25. Dermot has 240 counters. The counters are either red, or blue, or yellow, or green. 15% of the counters are red. So 15% of 240. So 15% of 240. So we can say 10%. We can get 10% by dividing by 10. So 24 counters is 10%. And if we half that, so half that, we'll get 5%. So half of 24 is 12. So 12 counters is 5%. So 15% must be 24 plus 12, which is 36 counters. And that's 15%. That's the number of red counters. 2/5 are blue. So 2/5 of 240. To find 1/5, we can divide by 5. So 1/5 of 240 is 240 divided by 5. So how many 5s go into 240? No 5s go into 2. 4 5s go into 24, with 4 left over, and 8 5s go into 40. So 1/5 is 48. 2/5 must be 2 lots of 48. 2 40s are 80. 2 8s are 16. 80 and 16 make 96. So 96 blue counters. And then we've got a ratio of yellow to green. So we need to know how many yellow and green in total. So if we add these two up, 36 and 96. So 6 and 6 make 12. 1 plus 9 is 10, plus 3 is 13. So 132. That's red and blue. There are 240 in total. So take away the 132. So 10 take away 2 is 8. 3 take away 3 is nothing. 2 take away 1 is 1. So there's 108 yellow and green counters, and we need to share them in the ratio 3 to 1. So it's 3 parts yellow, 1 part green. So that means there are 4 parts in total. So we need to share the 108 out equally between these 4 boxes. So 108 divided by 4, I'm going to half top and bottom. So that's 54 over 2, which is 27. So each box has 27 in it. So there are 27 green counters and 3 times 27 yellow counters. So that's our answer, 3 times 27. So let's just work out what it is. So 3 7s are 21. 3 2s are 6, plus 2 more. That's 8. So 81 green counters, yellow counters, 81 yellow counters. Question 26. Here is a cube. Work out the volume of this cube. Give your answer in standard form. So the volume of a cube is just the base times the height times the depth. It's the length cubed. It's 0.05 times 0.05 times 0.05. So the volume of a cube is just the length of the cube cubed. So we've got 0.05 times 0.05 times 0.05. Now we need to give our answer in standard form. So I'm actually going to do this calculation in standard form. So I'm going to say 0.05 is the same as 5 divided by 10 twice. And I can write that as times 10 to the power of -2. So 0.05 is 5 times 10 to the power of -2. So I'm going to do 5 times 10 to the power of -2 times 5 times 10 to the power of -2 times 5 times 10 to the power of -2. So I've got 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. And then I've got 10 to the power of -2 times 10 to the power of -2 times 10 to the power of negative 2. When we multiply indices, we add the powers. So we've got negative 2 plus negative 2 plus negative 2, which is actually negative 6. So I've got 125 times 10 to the power of negative 6. That's not in standard form. Standard form needs to have a number between 1 and 10 at the front. So I can change this into something between 1 and 10 by making it 1.25 times 10 squared. 1.25 times 10 twice makes 125. So now I just need to simplify these indices. And again, to multiply indices, we add the powers. So 2 plus negative 6, that's 2 take away 6, which is negative 4. Question 27. We've got a hexagon, ABCDEF. Angle CDE is twice angle BCD. So let's say BCD is x, and CDE is twice that, 2x. And we need to work out angle CDE, which is actually this one. This is the one we're working out. We need to know what 2x is. So we've got a hexagon. We need to know the total angles in a hexagon. We can say a hexagon is made up of 1, 2, 3, 4, 1, 2, 3, 4 triangles. A hexagon is 4 triangles, and angles in a triangle are 180 degrees. So we can say it's 4 times 180 degrees. We can also remember the formula, which is number of sides take away 2 times 180. Or another way, if you don't remember either of these two ways, you can remember in a regular hexagon, the exterior angle is 360 divided by the number of sides, which is 6. So the exterior angle is 60. The interior angle is 180 take away 60, 120. And then 120 times 6 will give you the total angles in a hexagon. So any of those methods, 4 times 180, 2 180s is 360, 2 360s is 720. So the angles in a hexagon have to add up to 720 degrees. So let's see what we've got so far. We've got 144, 129, 125, and 121. So let's add up what we've got so far. So 1 plus 9 is 10, plus 5 plus 4 is 19. So carry over the 1. 4 plus 2 plus 2 plus 2. So that's 10 plus 1 is 11. And 1 plus 1 plus 1 plus 1 plus 1 is 5. So we've got 519 so far. So 720, take away 519. So 700 take away 500 is 200. 20 take away 19 is 1. So it's 201 that these two angles have to add up to. So we can say 3x, 3 lots of x, is equal to 201. So if we divide both sides by 3, we will find x. So 3 doesn't go into 2. It goes into 26 times, which makes 18. So 2 to carry over. 3 goes into 21 7 times. So x is 67. But we want to know what 2x is. So 2 67s. 2 7s are 14. 2 6s are 12. Plus 1, 13. So our angle is 134 degrees. Question 28. Liquid A has a density of 1.2 grams per centimeter cubed. I'm going to quickly just jot down density is equal to mass divided by volume. You might also do a triangle with this. So density, mass, and volume. So we've got liquid A. So we've got a density of 1.2 grams per centimeter cubed. We've got 150 centimeters cubed of liquid A. That's volume. It's mixed with some of liquid B to make liquid C. And then liquid C, we're given the mass and the density, not the volume. And we need to find the density of liquid B. So we'll find the mass and the volume of C and A, take them away to find B, and then density is mass divided by volume. So let's do liquid A first. So we're missing the mass. We've got density and volume. So mass is going to be density times volume. So mass is going to be density times volume. So 1.2 times 150. I can get rid of the decimal. So if I divide this one by 10 and times this one by 10, it's 12 times 15. And 10 15s are 150. 2 15s are 30. So this must be 180. 180 grams. Then for C, we've got mass and density. We don't know the volume. So volume, if we multiply both sides by volume and divide by density, or in our triangle, if we cover over the V, we've got mass divided by density. So 220 divided by 1.1. I'm going to get rid of the decimal again. So times top and bottom by 10. And then we've got a nice easy division. 22 over 11 is 2. So it's 200. And that's volume, that's centimeters cubed. So now we can work out the volume and mass of B. So it's going to be C. So B is going to be C take away A. So let's work out the mass. So the mass of B is going to be the mass of C, 220. Take away the mass of A, which is 150. So that's 40 grams. And the volume of B will be the volume of C, which is 200. Take away the volume of A, which is 150. 200 take away 150 is 50. So now we can do density. Density is mass over volume, which is 4/5, or as a decimal, 0.8. Question 29. Write down the exact value of sin 45. So I use this to remember. So I've got sine and cos, a big square root sign, and everything over 2. So we've got 0, 30, 45, 60, and 90. And then this starts at 0, 1, 2, 3, 4. And cos goes backwards, 4, 3, 2, 1, 0. So we want sine 45. So that's square root 2. Sine and 45 meet at square root 2. And then that's divided by 2. So it's square root 2 over 2. Question 30. Factorize x squared minus 3x minus 18. So we've got 2 sets of brackets, x in both. X times x give us x squared. We're looking for 2 numbers that multiply to make 18, or negative 18. So it can be 1 times 18, 2 9s, or 3 6s. And they have to add up to give a negative 3. So which of these can add to give a negative 3? It's going to have to be the 3 and the 6. So plus 3, take away 6. And part B says solve. So we're solving this equals 0. So x plus 3 times x minus 6 equals 0. For this to be 0, either the first bracket has to be 0 or the second bracket has to be 0. So what does x have to be to make the first bracket 0? What number plus 3 is 0? So it's negative 3. And what makes the second bracket 0? It's a positive 6. 6 take away 6 is 0.